We're rolling.
Okay. I would like to welcome everyone that has joined us here today, and we're going to go through the material that we have accumulated regarding the NIST reports on the building failures at the World Trade Center on 9/11. Just to step back a little bit and look at a big picture of what we're doing here, we know that the buildings were brought down by controlled demolitions. That's our facts have proven that without any shadow of a doubt. But we have run up against the fact that there's a faction within the American Society of Civil Engineers that has taken this narrative that was presented to them by the government and provided a cover-up so that the information that we have is not being considered because there's been an alternative narrative that has been presented. And the engineering profession in the person or the organization of the ASCE has given their imprimatur to that story, and that is what's preventing the wider public from understanding what has happened. So what we've done is accumulated the evidence in the NIST reports that show that the narrative of those reports could not possibly be true. And that's the purpose of Project Due Diligence, to take that information out to the rank and file of the engineering community, particularly the civil and the structural engineering community, which was most directly involved in this, and point out to the engineers out there across this country that the information that was presented in the NIST reports purporting to explain how the buildings failed is inaccurate and doesn't meet our professional standards. And therefore, we need to get those organizations, starting with the ASCE, to go on record calling for a new investigation and a new study and a new analysis that will uncover what actually happened. Now, of course, the faction within the ASCE that has been able to pull this off so far is going to resist our efforts. We know that. How much control they have over the chapters down to the local branches and to the local communities, we're not sure of. And that's why we're conducting this project, because we want to find out if we are able to rouse the rank and file to call for a new investigation, if we can force the ASCE leadership at the national level to change their position and come out for a new investigation. So that's the purpose of Project Due Diligence. And we don't know what the result is going to be. We don't know to what extent this faction has control over the local organizations, but we intend to find out. So and in terms of our approach to the ASCE chapters, we will approach them with the notion that we are acting in the interest of protecting the ethical reputation of the engineering societies and in the interest of public safety. Because if we don't understand what happened, then we can't prevent future occurrences. And what we have now is an inaccurate report. Doesn't help us understand how to prevent future occurrences. So we're going to limit our investigation and our discussion to those aspects that actually affected the buildings in a material way. We're not going to talk about the criminal charges or the political ramifications or what has happened since then in terms of our civil liberties and our economy and so on and so forth. We're not going to touch those subjects because we're going to focus on our professional area of expertise and attempt to bring the engineering profession as a whole, or at least a major part of it, in line with the notion that we have to have a new investigation. After we've gone to the ASCE and determined what their position is, if they are willing to change their position, that would be great. If they aren't willing to change their position, well, then we'll move on to other organizations, professional engineering organizations across the country, and we'll take the same message to them. And hopefully, since they have not been directly involved in the process of covering up this crime, they will have much less inhibition about joining a call for a new investigation. So we're going to focus on the ASCE first because they were there on the ground. They participated in the cleanup, unauthorized illegal cleanup, and in the construction of a alternative narrative, which they have defended to the point where they refuse to discuss it anymore. So that's our purpose here. So all of you guys, I hope, have had a chance to look at the video, which is about an 80-minute presentation of the reports, our critique of the two reports, the one on the Building 7 and the one on the World Trade Center towers. So just very briefly, we've uncovered about 12 errors, as it so happens, errors, omissions, misstatements that are in those reports that totally negate the conclusions that the reports come to. Every aspect of the explanation that is presented is faulty and based upon either faulty input data, a faulty theorem, and omissions of relevant information. All these types of errors are contained in those reports, and we point out each and every one of them. Starting with Building 7, the collapse initiation theory that they propose, that a girder was pushed off of its seat at column 79, is impossible, couldn't have happened. We show that with all of our information that we lay out in detail. They make unreasonable assumptions. They input erroneous data, for instance, the width of the seat. They leave things out like the stiffeners on the end of the girder that would have prevented the flange from folding up. They leave out information that shows that the beams couldn't have expanded far enough to push the girder off the seat. Then they go on, they leave off stiffener beams that would prevent the northernmost girder beam from buckling. They leave off the shear studs on the girder, which would prevent the beams from being able to push it off the seat. So there's just a whole number of inaccuracies, omissions, and outright erroneous data that they put into that initiating event, which prevent it from happening in the way in which they speculate. And it's just full of holes. It won't work. Then even if you allow the girder to collapse and hit the floor down below on the 12th floor, there's insufficient impact to break that next girder down loose, and therefore the cascading effect won't happen. So the propagation, even if you allow the initial impact, the initial initiating event to occur, the propagation can't occur. And furthermore, the column, which supposedly then buckled because all these floors for 8 floors down collapsed, could not buckle because the beams coming into it from the south and from the west, the connections aren't broken. So the beam is not unsupported for the 9 floors that they claim, and it won't, the column isn't unsupported for the 9 floors that they claim. So it's not going to buckle, and therefore cause the rest of the columns to buckle. Furthermore, we know that the building fell at free fall for 2.5 stories. That can't happen and under any scenario with a progressive collapse of the type that they are proposing, because that would include the fact that all the connections, all these supports would have to go at once. And that's not happening in a progressive collapse of this nature. Then there's the fact that they ignored the high temperature that the steel was exposed to, which would indicate incendiaries. FEMA had shown in their report that there was such evidence. The NIST report simply ignored that. And then when NIST was confronted with this information by various engineers pointing out these omissions and these errors, they largely refused to respond and said that the information, their data input was classified and they would not release it because it would endanger the public safety. So their entire Building 7 report is faulty and erroneous and cannot withstand any kind of rational scrutiny. Then the buildings 1 and 2, they have a scenario where they claim that the upper part of the building fell on the lower part of the building and crushed it, and then was crushed itself when it hit the ground. That does not meet with the fundamental laws of physics. And they have a collapse initiation, again, theory that doesn't hold water, because the visible evidence indicates that the core columns failed first, and they have a scenario in which the perimeter columns failed first and thus caused the core columns to fail. None of the evidence that they have pointed to supports that theory. So that's just a very brief overview of the problems with their reports. So I want to pause now and go through any questions that you guys might have had in looking at the video and the PowerPoint presentation. Anything that you think is a problem or something that you would like to discuss. If you got a question or a comment, raise your hand and Richard will.
Can you put the link to that video in this group chat, Mazad, or I'm not sure if I've watched this one that you're discussing.
Well, I'm not sure that I can. I'm not sure that I can do that from where I am now. It's here. I'm going to share my screen with you.
It's it was in bulletin number 6.
Okay. Thank you.
Okay, now I'm sharing my screen with you, and what you should be seeing is the first slide of the PowerPoint. A critique.
Yes.
Is everyone seeing that?
Yes.
Okay. So just as we, I'll just flip through this very quickly. The reports, the official reports, and the privately funded reports that were done. We go into Building 7 first. We give you the floor plan layout and the girder and beams that supposedly initiated the collapse are shown. Basic floor plan photos, what it looked like before and what had happened. It collapsed in about 7 seconds that afternoon. There's a video of the collapse, which I'm sure everyone has seen. I won't bother with that. And we go through the debris, the damage to the building, the fact that there were fires in the building, and FEMA, nobody ever gave any decent explanation for why those fires occurred. Then their theory of how the building collapsed. The thermal expansion of the 5 beams pushed the girder at column 79 off of its seat, and that caused a cascade of floors down to the 5th floor, and that meant that column 79 was unsupported for 9 floors, and it buckled due to lack of lateral support. That's their claim. So then we go through the fires and list their erroneous assumption errors. So we can see here in this slide a listing of all the problems. They had the wrong bearing seat width. They took off the stiffeners on the girder. They assumed that the girder could move past the side plates on the column. They said there were no shear studs on the girders. These are all facts that can be refuted by the drawings. And then they said that the west and south girder connections were broken down to the 6th floor, but their own analysis said that that wasn't true. So that's an internal contradiction. They said that the floor failure would cascade down 8 floors. We showed that that couldn't possibly happen. They said there were no lateral support beams framing into the northernmost beam, which would prevented it from buckling. The beams and girders are notched to simulate their buckling due to fire in their model, which is an unreasonable assumption. You wouldn't get that from random office fires. They ignored evidence of temperatures high enough to melt the steel, documented by FEMA. And they showed radical deformation of the upper exterior and the east side when it collapsed, but the actual video footage shows that that didn't happen. And they ignored the fact that a simultaneous free fall of all 4 corners of the building would indicate that there would have to be simultaneous removal of at least several stories of the building in order to make that happen. And then they refused to respond to legitimate inquiry. So that is the summary of the problems with Building 7. Then we go through each of those problems in detail. The missing stiffeners, the temperature problems, the finite, we bring in the finite element analysis that was done at the University of Alaska Fairbanks by Professor Halsey. And he shows that if you have the, for instance, the web stiffener on the girder, the flange is not going to curl up and it's not going to fall. They admitted leaving the stiffeners out. They sent a letter signed by a public relations rep. No engineer signed it. So they basically evaded that question. Here's the column showing the side plate, and the Alaska analysis shows that when the girder is heated, it can't get past the side plate, so there's no way it could fall off the beam seat anyway. Then there's the question of the shear studs. They left the shear studs off. The drawings show that they're there. With the shear studs on there, the beams couldn't push the girder off because the girder is secured to the floor slab. Then there's the unsupported length of the column. Didn't happen because their own connections diagram shows that the column was supported at various points from the east, from the west and the south. So that scenario isn't possible, but if you let it fall, it's not strong enough, as this calculation shows, to break the floor below it. It only creates an impact force of about 166,000 pounds, and it would need something like 215,000, 632,000. Yeah, it's only about a fifth of what it would be needed to break that force loose, that girder loose. So these are the support beams that are missing in the upper beam. The notched effect that they inserted in their computer model to simulate the kind of effect that they would need to get total collapse once the interior columns were failing. That's unreasonable. And then there's the high temperature steel that FEMA showed was there. They just didn't even address that at all. Neither did they address the high surface temperatures that were reported and recorded by the USGS aerial photos after the collapse. And then there's the question of the way that their model looks versus how the the real one looks. And that I'll show you here. Their model deforms in a manner that the actual doesn't.
Go on mute. Dick, if you want to scroll your mouse bar up to the top of the screen, you can mute yourself by clicking the mute microphone.
I'm sorry, say that again.
Dick, roll your mouse up off on the top of the screen. Everybody can do this. Click on mute microphone.
Okay, then there's the question of free fall acceleration. Video footage shows that the roof line
Hold on, Roland. Hold on, Roland. Dick, roll your mouse
right now.
Yeah, roll your mouse up to the top. You'll see a microphone up there. Click on it. It'll mute you. Yeah, you got it. Good. Thanks a lot. Appreciate it. Go ahead, Roland.
Okay, so once it was shown that the building fell at free fall for about 2.5 seconds, they never addressed that. They were forced to admit it in their final report, but they declined to address what that means. So that's a big problem with their whole theoretical model. This is the graph showing that free fall. And the fact that there's column resistance during buckling that always declines to a certain point would always provide some minimum resistance so that free fall acceleration couldn't occur during collapse of the type that they are envisioning. So their model never accelerated at more than 60% of free fall. So that doesn't explain how the actual building collapsed at free fall for 2.5 seconds. So then we show out how that all of their presumptions were wrong. The girder width seat, the omitted stiffeners, the expansion of the girder couldn't move past the side plate. There were shear studs. The west and south girder connections weren't broken. Northeast floor failure couldn't cascade down 8 floors. There were lateral support beams in the beam G3005. It would have prevented it from buckling. The beam and girder notching simulating their buckling is not consistent with time phase weakening fire would produce. The evidence of temperatures high enough to melt the steel documented by FEMA is ignored. And their model shows deformation and collapse that the actual collapse didn't show. And then simultaneous free fall was never explained. So those are the problems with their report. They're of a major nature that completely negate the conclusion that they come to, and therefore we would ask for a new investigation. So when asked by engineers to provide their calculations and analysis that's substantiated, for instance, the girder walk-off and the impact force required to break through the next floor down, the NIST director refused, saying that it might jeopardize public safety. So their refusal to discuss that and the other problems that we have delineated completely negate the conclusions that they come to, and therefore the Building 7 report is not worthless to us as engineers. When we look at the Twin Towers, the video, we give some background to their construction. We talk about the aircraft impacts, the damage caused by it, and their column failure theory and their collapse hypothesis. Their evidence that the core column failed first, and our evidence that the core columns failed first, and the ASCE published progressive collapse theory that was used to justify their refusal to investigate the actual collapse. And we analyze that progressive collapse theory and show that it is full of input errors that make its conclusions wrong. Then we go into the south tower collapse symmetry, compare it with other office high-rise fires, and go into the destruction of the evidence and the summary of the problems with their report. And then we break it down by categories. So just moving through that very quickly, this is the background of the building construction. The steel, the plane impacts, the information that was put in the NIST reports regarding those impacts. We accept that information as being accurate. The 95th floor where the plane hit in the North Tower, we look at the North Tower more closely because we have more information about the North Tower. We know the damage that was caused to the perimeter columns by the aircraft. We accept that as was given to us by NIST. This is a short
the fact that they were designed to resist over 13,000 tons
showing that the towers couldn't have collapsed. They were designed to withstand aircraft impact, so they wouldn't have collapsed, and we show why that's true. And then we show that the wings would have been shredded and there would have been very little damage to the core columns whatsoever, which NIST admitted. And then this is a NIST representation. We know that the collapse initiation occurred at the 98th floor, and yet there was practically no damage to the core columns on the 98th floor. And there was practically no fire damage because the fuel, as admitted by NIST, that would have been exposed to the structural members on the 98th floor would have been minimal. And so the aircraft impact and the jet fuel couldn't have caused the collapse because the wings don't make it to the core. Most of the jet fuel burned up, and it didn't enter the building at all. The redundant steel frame redistributed the loads, and the building members had a factor of safety against vertical collapse. On the perimeter columns, it was 5-1. The central core was 3-1. So even though the aircraft impact damaged about 20% of the columns, it couldn't have caused those columns, the other columns, to fail. They said the collapse initiation was caused by the floor trusses, which were heated and sagged and pulled the perimeter columns in, and that progressed around the exterior and then caused the core columns to fail and the building to fail. So we showed that that's not possible, and they knew it wasn't possible because they couldn't get the kind of tension force that they needed to pull those columns in. So what they did was they applied an artificial 5,000-pound lateral load to the exterior columns where they were connected to the floor trusses, and they needed that 5,000 pounds at each of those connections to make the building behave as it showed up in the photos. So their analysis was, well, it acted this way, so we'll apply these artificial loads because that's necessary to make it happen. But that presumes that their analysis is correct. So the problems that they have is that there's no evidence that the sagging trusses could pull in the south wall of the North Tower, and the NIST model didn't generate those kind of loads, so they applied artificial loads. But the factor of safety for the perimeter columns and the core columns would prevent them from failing. They simply assume a horizontal propagation that they don't show any basis for. And then they rely on a global vertical collapse by a theory that was put out by University professor Zdenek Dezant, who submitted his paper to the ASCE journal 2 days after the event. The video evidence shows that the core columns are what collapsed first, so their whole propagation theory is not explained by the evidence. We show
collapse finally starts, the antenna started just a little bit before the exterior of the building started. And that tells us that the core columns let go first.
So that's Gene Corley. He was of the FEMA investigation team, and he is giving evidence right there that their whole collapse theory is wrong, because the perimeter columns don't give way first. The core columns give way first, and they have no explanation for why that might have happened. So that's why they don't address it. So if the transmission goes down first, that shows that the core columns went first. And that means that the collapse began with the central core. And so that's FEMA's analysis, which NIST completely ignored and went ahead with their own analysis. And so there's a contradiction there between what NIST said and what FEMA said. So this is all that information. And so what we're saying is that since the core columns fail first, which we know is due to controlled demolition, they would then pull the floor trusses in, and that was what caused the perimeter columns to be pulled in. And once that happens, as we know happened, because we have the photographic evidence here to show it, then the core columns pulling the floor trusses would pull in the perimeter columns, and that's the collapse mechanism, not vice versa. This couldn't touch that argument because it would indicate that something had damaged the core columns and they didn't want to go there. So looking at Besant's theory, he submitted this 2 days after the event. He said there would be a large dynamic load that would have occurred, and that would cause a powerful jolt that would overcome the reserve strength of the columns below. But problems arose with his theory. So he was forced to defend it in several articles. The first one in October of 2008. And his analysis breaks down in this way. He said that there was kinetic energy in the upper part of the building, fell onto the lower part, was greater than the total of the resistance of the buckling columns in the collapse initiation zone, the inertial resistance of the structure in that zone, and the structural resistance of the columns in the building below that zone. So he's got a mathematical notation, essentially, that looks like this. E1 is greater than E2 plus E3 plus E4. And Newton's third law says for every action, there's an equal and opposite reaction, which would mean that there would have to be a jolt when the upper part of the building hit the lower part of the building. But again, video evidence shows that there was no jolt. There was continuous acceleration, about 2/3 of gravity, no deceleration. So there could be no load amplification observed at any time. So McQueen and Zambodi published their paper, The Missing Jolt, refuting his analysis. And Chandler published his information on the descent of the top of the tower. Besant and Lee came back and defended it again. And Zambodi and Johns replied, pointing out errors in his paper. Then you got a long delay of a year. The Journal of Engineering Mechanics showed that their paper was rejected on the ground of one reviewer's comments, and they immediately responded to the rejection, showing that the rejection was unjustified, the reviewer was wrong, and they agreed to publish the paper. But then another year went by, and they didn't publish. And then 3 months later, they were notified that their discussion paper was out of scope. And in the meantime, they had been joined by another researcher, Zudolinski, and they wrote a full technical note addressing all 4 of his papers, submitted to the journal in May 2012, and was rejected again as being out of scope. Now, we have since realized that they cannot say that something is out of scope when it's discussing a paper that they've already published. So we have decided that we're going to submit a complaint to the American Society of Civil Engineers, and it's going to complained that the editors of the Journal of Engineering and Mechanics violated their ethical codes by not publishing the papers that were submitted rebutting the earlier papers. So that'll be filed here within the next few weeks, and we'll see how they respond to that. The problems were with his, very briefly, because this is important to know, he used the maximum design load for the mass of the upper part of the building instead of the actual working load, so that almost doubled that. He used a free fall velocity of the upper part into the lower part, but actual measurements showed it was only about 2/3 of that. So when you combine those two things, he had E1 too high by a factor of about 4. And they said that he said that the fall through the initiation zone didn't account for buckling resistance, which he eliminated completely. So he reduced that to 0. Measurements show that's not true. And he used a conservation momentum calculation of way too low a mass for the story below, only about 14% of what it should have been. So that makes that too low. And then he used the estimate of resistance in the columns in the lower part of the building, greatly underestimated that, and showed it to be, it's only about 31% of what it can actually shown to be. So E4 is too low by a factor of 3. So the inequality turns around, and E1 is less than E2 and E3 and E4 together, and the collapse won't occur. And this graph shows what he theorized versus what was actually measured versus what it would have been if their theory had been erroneous with input data. The building would have been arrested after about 2 seconds. And we got some photographic evidence shows that the upper 12 stories has already disappeared when the collapse has only partially occurred. So that wasn't happening. You can see that that's happening here in this video. The lower part of the building is not collapsing. The upper part of the building is collapsing. And it's symmetrical, which would not have been caused by plane impact on one side. Same thing with the south tower. You got even the top part of the tower there is leaning. Couldn't be causing the kind of symmetrical damage that you're seeing below. Then there's the other case of other fires. And then there's the case of destruction of the evidence. Now, this is a new slide here. I want to, this is about a 2-minute video that we just added, so I want you to see this.
When did you become aware that the steel from the World Trade Center was being sold off?
I think it was on the order of a week or so before we arrived on site on October the 5th, I believe.
So they were, in other words, the city was selling or was disposing of material within 2 weeks of the actual event?
I believe I was the first one to find out that the steel is being recycled. New York Times reporter Jim Glass told me 2 weeks after the collapse, and I tried to contact city and also New York Times reporters tried to make sure we can have access to steel to do the research. It was not happening.
I just think there's so much that has been lost in these last 6 months that we can never go back and retrieve. And it's only unfortunate. It's borderline criminal.
400 truckloads per day of material were taken away from the World Trade Center site and sent to China for recycling.
There were laws violated in the destruction of that evidence. And for the American Society of Civil Engineers to ignore those events is extremely disturbing and is a violation, in my opinion, of the professional code of ethics.
It was contrary to the way all investigations are done. If an airplane crashes, they seal off the entire area, nobody touches anything, they move it to a secure location, and they reconstruct an aircraft.
Normally, when you have a structural failure, you carefully go through the debris field, looking at each item, photographing every beam as it collapsed and every column where it is in the ground, and you pick them up very carefully and you look at each element. We were unable to do that in the case of Tower 7.
You can't do science when you are deprived of the evidence and when your hypothesis is the least valid instead of the most likely. When the most likely hypothesis in the case of Building 7 wasn't even mentioned. This is not science. It's trying to prove preconceived ideas.
So that little clip, I think, was better than what we had before. And so we included that. I think it's pretty comprehensive. This we modified this one slightly. This is John Gross. He was of NIST, and they decided what material to save, but they only saved about 1/4 to 0.5% of all the steel, a total of 236 pieces. Only one small piece from World Trade Center 7. And their testing showed that only 3 pieces out of that 236 pieces had experienced temperatures above 250 degrees centigrade and none above 600 degrees. So there's a lot of the assumptions that we even took as being true. For instance, in Building 7, that the beams were all heated to 600 degrees centigrade for the entire length of a 52-foot beam. That's way over the top. That couldn't possibly have happened. But even when we accept their premise that those beams were heated to 600 degrees over their entire length, their model still can't work. So you can see how they've changed the input data to maximize every assumption that they've made, and even then their assumptions can't come up with a model that will work for them. So none of the evidence supports their assumptions, but even then their assumptions don't lead to a model that will work. Again, here's the high temperatures that were recorded by the aerial photos, and this we're just going through here. And then we're looking at the categories. What kind of categories? They have defective theories about how the collapses were initiated in both the Twin Towers and Building 7. They make unjustified assumptions and errors in both the Twin Tower and the World Trade Center reports. And they have omissions and alterations of construction details in the World Trade Center 7 report. And they have errors in the calculations in the ASCE published theory, which supposedly proved why the towers collapsed. And they have internal contradictions in their World Trade Center report, where they say one thing on one hand and then another on another, like they say all the connections were broken on column 79 all the way down to the 5th floor, but their own data shows that they weren't. So those kinds of contradictions were never resolved in their own report. They ignore the evidence of high temperature exposure, and they refuse to respond to peer criticism. So those are the 7 categories of problems with their reports. And we believe that these conclusively show, without a shadow of a doubt, that the reports have no credibility and must be redone. So that's what we're asking people to go for, and we're asking them to go on record as an organization of the ASCE chapter to pass a resolution, and they have bylaws in the ASCE that allow them to pass a resolution and send it on up to the national under their rules and regulations, which I had right here somewhere. But anyway, section 5.4 of their rules and regulations allow them to pass resolutions and send it on up to the national for action. And that's what we're going to ask them to do. And we're asking the members of the audience to sign our petition, to disseminate this information to their colleagues, to donate to us so we can reach as many engineers as possible, and to urge any engineering organization to which they belong to call for a new investigation publicly. And then, most important, to join us and become a volunteer presenter to help us deliver this information to other local engineering organizations. Because, as I said, whether ASCE goes along with us and calls for a new investigation or not, we will be going out to other engineering organizations and asking them to take a position calling for a new investigation. So even if ASCE does not go along with us, we will do everything within our power to build a movement within the engineering profession so that we can isolate ASCE if that's necessary and put pressure on them to change their position. Whether or not they ever change their position or not, we cannot predict, but we will do everything we can to get the entire engineering profession aware of the deficiencies in these reports. And we will point out to these chapters that if they choose to do nothing, that is the same as endorsing the official reports. If they don't take a stand against it, then they're for it. So it's one of those things where they have to take an action in order to take a position that those reports are not adequate. If they don't do anything, they're signing on with those reports. So we recommend that the panel of a new investigation have our participation as AE 911 Truth, that it have civil, structural, fire protection, mechanical, physicists, chemists, and demolition experts on that panel, that they be vetted to make sure they have no conflicts of interest, that they have a staff to prepare documents and keep records, they have subpoena power, they have adequate funding, they have a reasonable timeline to investigate, prepare a peer-reviewed report, and that report to be released and broadly disseminated to the public. So that's what we're calling for in terms of a new investigation. It's very specific requirements. We don't want to have another investigation that turns out to be sabotaged from within like the last one. So at the end of the slideshow, there are references for each of the slides. Where there was information, for instance, slide number 3, we referring there to the FEMA report and the World Trade Center building report that they performed in 2002. The final reports of the NIST investigation on the buildings, the insurance companies that did a study, and the structural reevaluation that was done of Building 7 at the University of Alaska Fairbanks. So all those documents had input to the information in the slide for Channel 3. And people can go to those directly and look at the source information. We want to root out any errors or omissions that we may have in these reports because we want to make sure that they're entirely accurate. So at this point, are there any questions at this point that people want to raise about the video itself or the information in it?
Raise your hand if you have a question so I can pick you. Oh, there we go. Okay. Go ahead, Charles.
Yes, I've changed microphones. Can you hear me with this new microphone?
Yeah, you sound great.
Okay. Regarding the slides, at least the numbering of the slides prior to the addition of the new slide were slides 136 through 145, the reference pages. During our presentations, would it be possible to have a hard copy of these references with the URL addresses alongside the title of the reference? As it is now, the links will only work when you're in slide mode of the presentation itself. But it might be helpful for the participants at the ASCE chapter levels to receive copies of the reference pages during the presentation so that they could cross-check.
Hey, Richard, it's Tony here.
Hi, Tony.
Yeah, I can answer that. Charles, the references have hyperlinks. They can download the presentation off of there's a public site for Project Due Diligence as well as the presenter site. And the presentation, PowerPoint presentation, is available for anybody to download. I think it'd be pretty hard logistically for you to hand out a hard copy to everybody in the audience. But I mean, if you want to try to do that, I'm reluctant to ask people to do that. That you can tell the audience members, you can give them the timeline that we have in the on the website, or that you're going to hand out. That's going to have the website address, and they can look up the presentation and go to the references. You're going to show them that there's references to each slide in your presentation, and then you can tell them that the presentation is available on the Project Due Diligence site.
Okay, that answers that question. Thanks, Tony.
Seth. Oh, you're muted, Seth. You got to.
Sorry, I was on mute. I do have a question on the shear studs. So they claim that there were no shear studs on the girder. Why then do they include a calculation for the force it would take to shear the studs? Is that the force to shear the studs on the beams?
This is Tony again. I can answer that, Seth. That's the force to shear those studs in general. They're 3/4 inch diameter. Yeah, you would assume that's to shear the studs on the beams, but they were the same shear studs. They claim, just to flesh this out a little bit, they claimed there were no, initially in their draft report in 2004, they said there was no shear studs on the girders in the central core of Building 7. We're talking about Building 7 here. And then they said, then they amended that to say there was no shear studs on the girders anywhere in the building. But they have to shear the shear studs on the 5 beams, and they're the same size. And then the Aegis Insurance Company versus WTC 7 Properties lawsuit.
Thank you.
Where those 2 reports were in that court, in the court documents. Colin Bailey from the University of Manchester was part of the AWRAP experts report, and he testified that information he received in June of 2009, I believe it was, that there were in fact 30 shear studs on that girder. So that's where it was, and apparently this never released. We got drawings in early 2012. They only released revision up to revision 8. There was a revision I, and a number of people asked for it, but they wouldn't release it. But apparently, the people in that court case got revision I, and it has 30 shear studs on that girder. So, but coming back to what you're saying, I think all the shear studs are the same size, and that is what they were referring to in those calculations.
Excuse me. Hi, Kathy. Wanted to welcome you. Can you put your camera on your face and also mute yourself? I'm getting a lot of background noise. Does that make sense, Kathy?
I am muted. You can't hear me, right?
I can hear you just fine. So
you can mute yourself. It is muted.
Yeah.
It is.
Apparently not. Apparently not. If you roll your mouse up to the top, you can click the little microphone up there.
Okay, so I did mute it.
Now she's muted.
Now you're muted. You sound great. Thanks.
Yeah, let me just ask the fellow that just asked that question. Did that what I said answer your question adequately? About the shear studs, was that adequate?
Seth.
Yeah, I think so. Yeah, I was just a little confused going between those slides because the first slide, I think it was 38, says that they didn't assume shear studs, and then the next slide is calculating, or they're calculating, force for it. So it was just a little confusing to me, but I think I understand it now.
Yeah, well, let me just explain a little more detail. The reason we did that, we're saying, okay, if there are shear studs, now how much force would it take to shear them? And you have the 5 beams, 52-foot long beams approximately. Some were 53, some 52. They had their shear studs failed. We're showing that those beams would buckle before they could ever shear the studs on the girder. So that's the reason for using their calculation for shearing the shear studs. All right.
Okay. Yep, that makes sense.
Okay.
Okay, any other questions?
Roland, you might want to stop sharing your screen now, and so we can see your pretty face.
Oh boy.
There we go. All right.
Okay.
Roland, I've got another question regarding the new slide. Is that currently on the AE 911 website?
Who's
for
talking?
download?
I can't quite tell.
That's Charles.
This is Charles. If we go back to the same URL where we downloaded the original PowerPoint, is the new slide now added to that?
I can answer that again. Sorry. I was heavily involved in this presentation with Roland, Charles, and everybody else. It's Tony again. I updated the presentation to add that video, and then that particular video was put together by, I think, by Ted Walter, and it was on AE 911 Truth's Facebook page. And I found that after we put the presentation out. Ted has the updated presentation. It's going to be on the website that you're used to going to. It's not there yet. I think I checked yesterday, but it'll have the URL for that video on it. Does that answer your question?
Yes, it does. Thanks very much. And also one other question. Professor Halsey at University of Alaska Fairbanks completed part of his analysis, but he has another report forthcoming that will speak more to the probable causes of the collapses. Do you have a date for that yet?
You want to speak to that, Roland? I can speak to it.
Go ahead.
Yeah, he's in the process of, they're trying to do she showed that the NIST report claims are impossible. We have that part. The next part is trying to show what the probable cause was, and he's in process in doing that. He's calling it a progressive collapse. What could have caused a progressive collapse? You know, did all the core columns have to fail? The kind of thing that enters into that is the notching of those beams that NIST did. That creates a device where if the core falls, the beams lose stiffness and they just become tensile members like a cable, right? If you notice those beams, the beams outside the core, between the core and the perimeter in Building 7, in that slide that we show in the presentation, they're notched, I don't know, maybe 7-8 feet apart at the bottom on one end and at the top on the other end. They go through the flanges of the bottom and up through the web, and on the other side, further down, they come in from the top and goes down to the bottom. They just leave the flange. And the flange has enough strength as a tensile member. So he knows about that. He's incorporating all this stuff. It's, you know, there's a number of iterations, and the finite element analysis, to get buckling to occur, it's mesh sensitive. You know, it's a lot of work for the finite element analysis, and he's working through it right now. So I don't believe we'll see that for a while yet. But we don't need that.
Does
We
that mean
don't need
summer
that for what we're trying to do. Okay, what we're showing here is that the present reports basically are impossible. Okay, if you look at their whole collapse initiation theory in Building 7, okay, the first thing that happens is they shear the studs along those 5 beams, 28 shear studs each. Then they say that the expansion, that the seat was narrower than it actually was. They said it was 11 inches at first. They could only get 5.5 inches of expansion out of those 52-foot long beams. And then when we got the drawings in early 2012, it showed that seat was 12 inches wide. So 5.5 inches doesn't hack it. In addition to that, you have to remember that girder, it's a W33 by 130, has a big radius, 1 3/16 radius from the web to the flange. So you'd probably need 6 1/4, 6.5 inches to get anywhere near the bending stress you need to start bending that flange. But now there's a second thing, and then they left off those stiffeners, those partial height stiffeners, 18 inches high, 3/4 width, that go from the web out to the flange. They increase the sectional modules by 80 times if you do the calculations. So they left them off. And we got them to admit they left them off, and their answer is, well, our analysis said those stiffeners were for web crippling, which is true. Our analysis showed there was no web crippling. Why you would even do that, you can't say. It's absurd. And they left them off. It's obvious why they left them off, because the flange will not curl up with those stiffeners on there. In addition to that, if the beams can't get to 600 degrees without that girder in close proximity getting hot, they say it's 500 degrees. That causes 3.6 inches of expansion of that girder, 1.8 inches aside. It puts it against the flange, the face of the flange of column 79, which has side plates which protrude 1.8 inches. In the Alaska study analysis, it shows the girder gets trapped behind the side plate, so it can't go anywhere there. ARUP even admitted to that it couldn't be pushed off, invalidating NIST analysis. Then they said the beams got to 800 degrees and sagged and pulled it off to the back, to the east. But their problem is they can't then, and this can't either, even if the girder did fall, you don't have enough energy to break through the next floor down. And the way that was learned is when we got the Aegis report, NIST just made that claim, that assertion. With the Aegis report, the guy whose name is Nordenson that did that part of it, after the finite element analysis, it said the girder would be pulled off to the east. He tried to show that it could break through the next floor down with a point load. Now, you only need to bear in mind, you're going to have the girder with the 5 beams connected, leaning down towards column 79 and impacting the next floor down. It's not a point load. The girder is going to deflect, and as I'm sure you're all aware, when you have deflection, it limits the shock amplification, right? So when you do the calculations, and we do them in the presentation, we show it. It's much less. He needed, like, a point load is an infinite stiffness. Well, it's not. It's far from an infinite stiffness. You can calculate it, and we did a finite element analysis to show what the natural frequency was. And with that, you can come back and get the stiffness. We did that. When you add that stiffness in with the girder below, because there's springs of series, it always takes the lower spring dominates, because it's a reciprocal rule. And if you're 1 over a big number, that's almost 0. So the one below doesn't affect it on the 12th floor. But the girder that's falling is going to deflect like 32 inches. It's not a point load. So we showed that the ARUP analysis was an error, that they don't have enough energy to break through the next floor down. And by default, neither does NIST. But NIST never even showed us their calculation. It wasn't until we got the ARUP analysis we were able to critique that. And so we have that information now. It shows that the whole thing, none of it can work. It's impossible. And then on top of that, you only need 2 girders, lateral support from 2 orthogonal directions, like an exterior corner. Well, so NIST needs to not only get that north girder down, but there's a girder coming in column 79 from the west and the south. They say they broke by thermal expansion, but their own data, like Roland told you, shows that they only ever have 3 stories without lateral support. Column 79 could take at least 5 stories without it. So they can't get there. They can't get there. They can't break through the next floor down, so they don't leave it unsupported from the north for 8 stories. And then it's not unsupported from the south and west for more than 3 stories. So they can't ever get column 79 to buckle. And that's all been shown by the University of Alaska report also. And the only thing we're lacking now is saying what, and this was your question, what actually caused the collapse. And the likelihood is going to be the core, just like in the towers, because the whole exterior comes down simultaneously in building 7. All 4 corners come down simultaneously. And in order for to have that happen, everything in the interior has to be coming down simultaneously. So what it looks like, they talk about this whole East Penthouse thing, and you guys need to hear this. It looks like that was a separate and distinct event, that it only came down in the top of the building. And the reason I can say that is you can only see daylight to the very top windows. The shock wave goes top to bottom. There's only dust coming out of the north side after the exterior falls. If that whole east side interior had been coming down, like NIST tries to say, before the rest of the building collapsed, you'd have seen dust coming out of the north face on the east side. There is none. You can watch videos. You won't see it until the whole exterior comes down. And then the windows only break from the top, the roof down 15 floors. So that means there's something hit inside at the top stories up there, and then a shock wave progressed downward. The windows would only break down 15 floors or so because the shock wave is going to dissipate. So there are the reasons that what really happened is most of that core was intact, maybe up to 45 floors on the east side and the rest of it, and it came down simultaneously. And that's probably what the University of Alaska is going to find. That's the only way that that whole building, the whole exterior, could come down simultaneously the way you see it. Because when the core comes down, those beams, the beams between the core and the exterior, are going to pull simultaneously in the walls. Now, they would start it in the center, like any controlled demolition would do, just a split second earlier in the center, so you get the pull in, so you stay within the footprint. You want to pull it in while you're coming down. And that's what it looks like happened. If you can imagine, if the east penthouse was still there, what you see in the video is the center of the roof go down first. It's not actually progression from east to west. That's a lie, is what I believe. Okay, because they can't get it going. And in addition, Steve Dusterwald looked at this. He said you'd have to break 400 connections a second. I mean, all you guys are experienced people. Can you even imagine that? I can't. So, you know, they can't get it off the ground. They had to leave a lot of things out, or ignore things, or actually distort things. Either omit, distort, or ignore to make what they're saying work. And the only way to get away with it is if nobody like us knows about it. And you know, what we're trying to do here is tell other people like ourselves that there's a lot of deficiencies here. There's major gross distortions, and it's not possible. And hopefully, you know, we'll get people to say, you know, we want something real done on it. So that's all I had to say there. Sorry.
All right, good. Well, that's, I mean, it goes into, Tony has been looking at this stuff for 12 years, and he knows it better than anyone that I've run across. And he's, you know, he's thought this thing through, and I think his answers have proven to be accurate. So any other questions or comments on the video itself? I want to go into how to deal. A number of people have raised questions, so I'm going to go through some of those because I know that not everybody is here. Some people are concerned about what do you do, in particular with the ASE presentations. You get somebody in the audience that's very antagonistic, very negative, brings up some point perhaps that you don't have the answer to, and how are you gonna deal with those kind of situations? And I think that that's a real concern. Nobody wants to stand up there and look like they don't know what they're talking about in a matter of this serious import. So I think that, and I've talked about this with a few people, when people ask questions that are clearly antagonistic, I think what you have to do is just go back to listen. The whole subject matter that we presented here in detail indicates that there's something seriously wrong. Now, if there's some error or some problem with some aspect of some detail, that's really not conclusive that everything that we're talking about here should be thrown out. If I don't have the answer to that at this particular time, I will note the question and get your contact information, and we will get back to you on that information. We will respond to all legitimate criticisms. And that is part of the peer process that we want to reinforce should happen with this report and with any report of this nature. Unfortunately, what we're saying is it didn't happen with the NIST reports because they refused to release information that would have allowed a peer review of what they were putting forth. And the same thing with ASCE and the publication of their theory about why the towers collapsed. We had a violation of the peer review process by both NIST and ASCE, and that's one of the big problems that we're trying to bring out into the engineering community right now so that we can correct that. We have a process that we go through in the engineering community and the scientific community. It's called peer review. All the evidence, all the facts, all the theories, everything that has gone into the construction of a model have to be critically reviewed, and any information that counters that presentation has to be satisfactorily answered, or you have a problem. And that's what hasn't happened so far. And we will not follow that procedure. We are open to peer criticism. We will answer questions. And if we don't have them off the top of our head during this presentation, we will get back to you and respond. So I think that's kind of the approach that we have to have, is confidence in that what we're doing is actually following a centuries-long tradition of scientific inquiry in our field. And that's what we're bound to do, and that's why we're doing our due diligence to make sure that that does happen. So I think trying to, deflect these questions in such a way so that it doesn't become a personal confrontation as to, our personal strengths or weaknesses in making this presentation, gets down to the process itself and what we're following through with. So that's one of the questions that has been raised by several folks. Another question that's come up is making contact with the chapters in the beginning. In other words, how do we approach them? What do we say? And how should that be done? The more I talk about this with people, the more I'm convinced that we should have perhaps a select few of our volunteers to specifically do that contact information, and that they follow a pretty closely a script that has been outlined in terms of how we approach them, because there's going to be a lot of variation. They've got ASC's got 160 chapters out there, 160 branches that we're going to contact, and we're going to see how they respond. And in order to gauge how they respond, we want to have a uniform approach to how we approach them, so that we have certain points that we make, certain elements of our discussion that we want to emphasize. And that way, when they respond, we know that we're getting at least the range of responses that we get is in response to the same question, meets the same criteria. So I'm putting forward at this point that that's the way we should do that, as opposed to having each of you make a contact with a chapter, which of course puts more work on you, and then you have to follow up and so on and so forth. We can do that in-house and get you the positive responses and say, okay, this chapter has agreed to have a presentation. You can now follow up and arrange the specifics of when and where and so on. And that way you don't have the additional responsibility of making the initial contact. It's like a cold call with sales, I mean, and it's people that do it should be good at it. They should be practiced at it. They should have done it over and over again. And we should train them in that regard so that when that happens, we get the kind of response to a uniform approach that we need. Because we're going to write up a report when this is all over. We're going to say we approached these chapters, and so many of them said we couldn't perform, and so many of them said we could, and these were the responses of the ones that we could, and we're going to put all that out there as a report to examine, to help us guide our future actions as to what we're going to do with this report once we've completed project due diligence. Project due diligence is just a step in our approach to how we're going to turn this situation around and get another investigation. And it's a tactic. And we're beginning with ASCE. We're going out to the engineering community as a whole. We'll see what the engineering community has to say. I have every confidence that most engineers, when confronted with this evidence, are going to say, yes, we need a new investigation. Hopefully, I'm not wrong. But my experience dealing with engineers, all my adult life, I have every confidence in their ability to make that kind of decision once they know the facts. So we need to control our approach and make sure that we adequately give these engineers a chance to review this information, give ourselves the best chance to get this information in front of them. So that's what I'm going to propose at this point, as opposed to originally we had thought, well, we'd have each of the presenters make the contact in their area. I think that gives too much variability to our approach and therefore makes it harder for us to make a realistic evaluation of what we've discovered.
Hey, Roland, can I add something to that? Yeah. I spoke to Oswald Herrero. He couldn't get on with his computer. The Google was giving him a hard time, and I couldn't get him out of it. It didn't give him any continued type thing, but we'll send him the video of this. He's, just for everybody's edification, he's an 82-year-old structural engineer who was an editor up until somewhat recently for one of the journals for the ASCE. He was involved, he was an editor from 1982 for 25, 30 years. And he's very involved in this. He had Roland give a presentation last June to the National Society of Professional Engineers, Alabama, Mississippi chapter. And that's what helped give us, that was one of the things that caused the genesis of this whole thing, along with the University of Alaska study. So I mentioned to him, I spoke to him for like 25, 30 minutes, even after we tried to get him on here. And I explained to him that people like him are critical for contacts. I mean, everybody here is mature. We all know sometimes, you need to know somebody. So that's the kind of thing we're going to try to, with Roland and these few volunteers who will be doing the contacts, we'll try to make those contacts. So that relieves everybody else of the burden of also cold calling. And that's what Roland was trying to say. Mostly everybody, you want to know this information fairly well. And from the numbers I saw on the video, the views, it looks like everybody's been looking at this pretty hard. And that's appreciated because it'll help, in giving the presentation. And there's a questionnaire in that presentation to see if people would like to also be presenters. It's just a 3-question questionnaire along with the timeline that we were asking to have you hand out. So, but Oswald, people like Oswald can be very key in getting contacts. And that's the kind of thing behind the scenes. That's what I wanted to mention to you. So go ahead, Roland. I'm done.
Okay, so the other thing I want to discuss is questions of logistics, deciding on a launch date, transportation and lodging issues, money issues, whether we can have 2-member teams in some cases, and future webinars and preparation of the final report. So let's, the launch date, we were hoping to get this webinar out to all of our volunteers in 2 weeks, but I don't know that that's going to happen now based upon our attendance rate today is only about 50% of the people that we had committed to show up. And I think we have some technical problems that we've got to solve that might largely be responsible for that. So we'll be contacting the folks that didn't show today and finding out. I know with Stephen Dusterwald, he was having some kind of a technical issue. He just couldn't make it. And same thing with Ozzy. So we need to solve those problems to get the future webinars running more smoothly so that we can get everybody here. And then I don't think we can really decide on a launch date until we feel satisfied that we've got everybody properly prepared. So I'm going to put that discussion off until we've had a chance to solve these technical problems with the webinar.
Roland, I would just interject there, and somebody else can say something. I mean, the people that are here, ladies and men, they feel they're trained enough, and we have a place they can give a presentation. Do we have to launch it all at once? I understand we're trying to do a broadside per se, but I don't know how much further behind the others would be. I mean, I don't know. We could take a vote. I mean, if some might be sitting there with bated breath, waiting to go out and give a presentation, if we have a place that is willing to allow us to do that.
Also, is the strategy to start at the smaller chapters?
Go ahead, Roland.
The strategy would be to start at the chapters that are closest to where you guys are located. So, for instance, Michael, you're in Fort Collins, right?
Yes, I am.
Yeah, so we would.
And just to add this, I am an ASCE member, and I presented to our branch in May of 2014. They were accepting of it. I was naive and didn't realize there was the resistance throughout the organization at the time. There were about 60 members who attended that meeting. I really did not have much follow-up in the way of questions from those folks. It kind of left them numb. Realizing something they had not noticed before. But the presentation to me right now is much more professional than what I was able to give at that time. But the problem I have is I've already approached them. There are other branches in Colorado and Denver and Colorado Springs, and I believe there's one on the western slope. But I don't know that I have I'd be glad to join somebody else in doing a communication with them, but they may not be ready for another presentation yet.
Well, this is Tony again. Michael, that was 4 years ago, and we've learned things since then. This whole thing with the AROP not being able to break through the next floor down, the Alaska study, it's more or less an update. If we could get in there with those 60 people or somewhere about that again, I think that would be a great springboard, and you might get others to join us. So if at all possible, if that could be done again, and you do have, this is an update, and a significant update, and by your own words, it's a professional presentation. It'd be nice if we could get back to that, and then in this case, you're asking others to join us, right?
Yes.
And also, we'd have a specific proposal that they pass a resolution and send it on up to the national, calling for a new investigation. So that makes it, instead of just leaving them numb, it gives them a choice about, deciding what they're going to do.
Yes. And that didn't happen in 2014. So
yeah, I mean, I had the same reaction when I did the presentation down in Alabama. Everybody was just kind of blown away. There was nobody there that stood up and said, although there were some of the members told me that there were some murmurings in the back of people that are, say, diehard Bush supporters. We were in the South, and they couldn't allow any criticism of anything that happened under the Bush administration. But they weren't brave enough to get up and contradict anything that I had put forward, because there's basically no contradicting it.
Yeah, I did have a reaction with that from an individual afterwards, saying that I had no place presenting in that organization that type of information. Of course, he says, if you don't like this country, just leave it.
All right. Yeah. Yeah. So that's the kind of opposition that we're facing. It's not based upon engineering principles or professional, criteria. It's an emotional reaction to hearing some very bad news that upsets their whole worldview.
Right.
I would consider that person immature, and they probably shouldn't be an engineer. but because we have to accept reality. So, I mean, if that gives you any consolation, yeah, that wasn't, if they can't challenge you technically, like, I think we can, you can, I mean, outwardly, you don't want to react, but inwardly, you have to dismiss that kind of individual.
Yes.
Right.
Yeah, we're not ever going to convince the diehard element that is going to go down with the ship. I mean, they're not our target. The vast majority of people are not there. They're somewhere between where we are and where they are, and those are the people that we're aiming our message at, and those are the people that will be successful in reaching. I think I have a pretty good feel for what, the mindset of your average engineer. They want to know the facts, and they're going to make as rational a decision as they can based on those facts.
Yeah. The problem we have right now, they don't know. And what we're trying to do here is to inform them. And 9 times out of 10, if not more than that, most engineers, like Roland said, are going to come. They're going to realize there's a problem. As soon as you see that they left those stiffeners off, you have to say, whoa, what are they doing? Things like that. So you shouldn't have a problem except with an individual like that just doesn't want to accept it for emotional reasons, and they have to be dismissed in your own mind. You just say, well, sorry you feel that way or whatever.
Okay, so transportation. Yeah. So again, in the outreach, we're going to try to find ASCE organizations that are close to where our volunteers are to minimize the expense and the time that's involved in reaching these organizations. So we would look at your physical location. We'd look at the ASCE map of their organizations, and we would contact the ones close to you. And then if we get a positive response, we would give that information to you, say, here's the contact information, here's where they're located. And then you would work out the actual presentation itself. We will send you a thumb drive with the video presentation on it, so that you can take your laptop or use their laptop. Most of these places, I'm sure, have facilities where they hold their meetings or their conferences, and there's possibility for PowerPoint presentations. You got the PowerPoint on the thumb drive, and you just plug it in and run it, and then conduct the question and answers, comments afterwards, and pass out the literature. Hopefully make some contacts, some people that are willing to help us, get the resolution on the floor, or at least get them to consider it at their next meeting if it's not a business meeting, and then follow up to make sure that the resolution was in fact passed, or if not, what happened, so that we can compile all that information into our, chapter by chapter, branch by branch data of what exactly happened. And then we'll be able to put pressure on the national organization. If we've got some of these resolutions passed, we can say, you've gotten these resolutions, what are you doing about them? And we'll be able to exert pressure from the bottom up. That's what we're trying to do here. We're trying to exert pressure from the bottom up. We know we have a faction in place that was on board with the cover-up. How strong their control of that organization is, we're going to find out. But we'll move past them once we've compiled this information and reach out to the entire engineering community. So money issues. If we will ask people to make donations as a nonprofit, they can make donations that are tax deductible if they want to claim it, and we can use that money that we raise at these meetings to defray your personal expenses. If we get more money than what your personal expenses were, then you can turn it back to us. If it's not enough and you need more, you can let us know and we can make up the difference. So that is how we'll deal with the money issues, and we'll have a methodology program for carrying that out. Some people ask about having more than one member, like Mike just brought up. We can do that. We have, fortunately here, for instance, Charles Coleman, who's also a retired commercial pilot. Charles has volunteered to travel to other locations to put on these presentations. So that will be very useful for us, very helpful. And he's got structural background and has paid close attention to this information. I'm sure he would be one of the people that we could call in to back up to provide a partner for other people that are want some help in doing this. Nothing wrong with that. And if there's other people in your area, for instance, we've got 3 people in the Las Vegas area, so we can combine there. Anywhere Southern California, we have a couple of people. Anywhere where we have more than one presenter, they can do that together if that's their desire. So we'll arrange that in every case that we possibly can. We got another webinar scheduled for next Saturday. There's 15 people signed up for that. In addition, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 people that didn't make it today. So we'll try and get those scheduled for next weekend. But I know some of them can't make it because they had already told me they couldn't. So we'll have some future webinars and try and get everybody. In addition, we've recorded this one, and they can then go on the website and watch the report of this one. So if that would satisfy them, then they don't need to go to another webinar. Finally,
this one's on YouTube, Roland.
Okay.
I will be sending the link to Roland, and he'll send it to everybody. So they may not even need to come to a specific webinar themselves.
Right.
Richard, I would suggest we put it on the Project Due Diligence presenters website. It's one web page that's the web page everybody's going to go to. So that would be easier rather than having a link floating around. We just put it on there.
Sure. And I don't know how to do that. If you have a connection with Ted about that,
yeah,
maybe
Ted does.
You can send it
yeah, Ted does. Yeah. Roland, I have a question as far as the donations. There was some money involved as far as expenses and the donations. So we would hope they would defray that. But if I was one of the presenters, and I guess I will be in this area, do we have a donation box? I know you said we'd come up with a mechanism for that. Do we make up donation boxes, something like that? I don't know what you used in San Francisco. Did you have a box that people could put money in?
Yeah, we just took a cardboard box and put it on the table, and people threw money in it.
Right. So, would each presenter make up his own little box and have then label with donations? I mean, how do we do that? We need to say what we're going to do, something like that.
What's the easiest on that, Tony, is, and I have a bunch of them. They're black, folding, snap together boxes. They're the size of a shoebox, and you can put a little sign on there, donate to AE 9/11 Truth. I'll run and get mine to show you guys. They cost about $5, so it's really helpful.
Well, we can give that information to everybody, and they'll have a thumb drive. We're going to send the thumb drive with the video that Dylan Avery is finishing up for us to each presenter. So they'll have the thumb drive, and then they need the timeline and the questionnaire with them for the presentation. I'm just trying to say what the few things they need for the presentation are. The thumb drive, the timeline, single page, and the questionnaire, and then they're going to need some kind of thing to have a little donation box. 4 things. Trying to keep this simple and straightforward, the KISS principle. So, do we provide that to everybody? I would think, do we mail it to everybody, or do we tell them to go out and buy a box that looks something like this? Maybe it's something like that. But we're trying to keep this as straightforward as we can, guys and ladies. So, you know, as you are well aware, I'm sure, as soon as you start getting too complicated, things get out of control. So it's not many things we need to remember that way.
One of the things that we're going to need is we're going to need everybody's mailing address, because we're going to have to send this stuff out to them. So,
well, you should send a bulletin out and ask them all to send you their regular mail address. Yeah.
In my next bulletin, I'll include a request for your mailing address, so that we can get this information out to everybody.
Yeah, you mean the thumb drive and maybe a donation box that we can just mail. Yeah.
Yeah.
And how about printing up the timeline and the questionnaire?
Right. We can do all that together.
Okay. And we send them a kit, more or less, right?
Yeah.
Okay. And I think that's the best, and that keeps everybody on the same page. And all they have to worry about really is being familiar with the material. And once we find a site, you know, a branch or engineering organization near them that wants the presentation, they're ready to go. They have their little kit, and they give they set up on when the presentation is going to occur and where, and they give it, and they get response from the audience, and they have to do a feedback once they've done the presentation. And that's on the Project Due Diligence site, presenter site. There's a feedback form. In case you haven't mentioned that yet, you might want to go through that.
Yeah, the feedback form is right on the site, and once you've made the presentation, you fill in the boxes there, and it's pretty straightforward. We do want especially contact information. Of course, we want to know whether they accepted the idea that they were going to pass a resolution. We want that contact information, who you spoke with, who the chapter officer was that you were dealing with, when you spoke to them, what they said, etc. It's basically compiling that data so that we can refer to it.
It's electronic. It's a survey type form. You just go in and fill in the lines, and most of them are check boxes.
Right.
So that's after you give the presentation. So each presenter, we need to get a kit to them. Their part is understanding the information and then setting up. Once we have a site that's agreed, is to set up a time, give the presentation, and then do the feedback. So it's basically you know, 3 things they have on their plate there.
All right. Anything else?
Yeah, this is Ibrahim Saudi, and I have a few comments to make, if I may.
Sure.
Regarding the presentation itself, and it's an idea that I will throw out and you guys can think about. Is it possible to have Dr. Huxley and Tony, for example, make actually a videoed, recorded presentation, and then the job of the presenter actually would be to run that, let it run, let people listen to it, and then the presenter now will either answer questions or take the questions if the presenter cannot answer him or herself, do the survey, get the feedback, and the rest of the stuff. I will throw the idea out now, and you guys can think about it. I think it would be very effective, actually, to have the voice of Dr. Huxley, as well as somebody very familiar like Tony, for example, or another structural engineer. I think Dr. Huxley himself is a structural, so having Tony as mechanical would be a plus. So here is the idea, is to have actually a recorded presentation, and then the presenter will actually run it, and then take the questions and so on and so forth. That's number one. Number two is regarding the antagonistic questions and stuff like that. I have spoken myself quite a bit in public, and I found it a very effective technique actually to pre-empty those comments even from the start, to say I'm not here to cause people any emotional distress or anything. I'm a professional presenting science and engineering, and I'm willing to be challenged in what I'm presenting. So the issue here is not political, it's not emotional, it's no. I am here and I'm challenging you to tell me if I'm wrong, but prove it with science and engineering. When I say that publicly at the beginning, it actually reduces quite a bit of the negative reaction that comes later, because the person will be afraid to show actually as an unprofessional or emotionally immature, like it kind of preemptive the thing. The third thing that I want to say is, I don't know if it has been done already or not, but I think if I remember correctly, it was Noam Chomsky who actually ridiculed or kind of chastised somebody in South California, Florida, who said, well, if you guys find something about engineering, why don't you go to a local university, civil engineering department, and tell them what you found, and then let them have that. And then I think that might have been actually the driver behind why this whole thing started, actually. So is Noam Chomsky now aware that actually the University of Alaska did that report? Are we planning on actually asking him now to be a voice out there for us that, yeah, we did what he actually told us we should do, and here is the result? Is he going now to use his outreach, his very long reach in the world, and actually publicize this study that he actually called for himself? That's all what I have for now. Thanks.
I can handle the third one, or Roland, if you remember the first two. You want to answer the first two, and then I'll talk about the third one?
Well, I'm not clear about the first one, because you're saying that to have Professor Halsey do this presentation, I'm not sure that that's possible. I mean, he's not.
Well, he may not be aware that you're going to get a video of Roland doing the presentation. Okay, I forget the fellow's name. Is it Abraham?
Abraham, yeah.
Abraham, you're going to get, Roland did a presentation in San Francisco that was videoed. And he did an opening statement, which I think does what you're saying in your second question, which I think is very good, to preempt that you're not there for political purposes or to cause anybody emotional distress. I think that's a good idea, and everybody can use that kind of line themselves. So you're going. I think those two questions are answered. Roland's doing a video. Everybody can just show that video. We're going to give you a thumb drive with that video on it. You can show that video. That's what you can do.
Tony,
and then,
also, there have been previous presentations by Halsey, and there will be another one when he comes out.
We're not going to do Leroy's presentation. This presentation was done by Roland and I, 4 engineers, with Leroy's information. I worked with Leroy quite a bit. We have what we need here. Roland Angle is a 76-year-old structural engineer with 50 years experience. That's where it should come from. This is what we're doing. He's running this project. So that's what we have. It contains the University of Alaska information. We don't need to go there. So Abraham, the first question's answered. You're going to get a video. It's Roland Angle giving the presentation. Okay, and the second question, as far as the preemption, Roland gives an opening statement, for a 5-minute opening statement or opening remarks, where he talks about the politics and that this is not that. This is strictly looking at the facts, and everybody can mention that they're not there to cause emotional distress. You want to look at the facts, that we have a responsibility. The 3 paragraphs on the project due diligence page express that responsibility. You know, our job is to make sure things are answered properly when it comes to structural failure or things of that nature, engineering failures. And we don't believe that's been done, and we want to inform the engineering community of that being the case here. As far as the third question, Noam Chomsky, I've had interaction with him. The last interaction, when I told him basically that, look, he also said, Abraham, he said you should write a paper to a journal. Well, Richard Johns and I did that. That's talked about in the presentation. And we saw what the ASE leadership at the top did. They stonewalled it, and they basically they stopped it. Okay, they had no technical basis for it. So they were playing politics. And Noam Chomsky, when I showed him that, and I showed him Professor Robert Coral's papers, which were published in journals, and Noam Chomsky's answer to me was, "You're talking to the wrong guy." That's what he said to me. Okay, this is by email. That was within the last couple of years. So I can send something to Noam Chomsky talking about the University of Alaska too. But I already broached that with him. That look, we've done papers. Okay, so he doesn't want to really talk about this anymore, or at least with people like me. He's not prepared for that.
Yeah, that's correct. And I also took in a binder, a 3-inch binder full of 72 peer-reviewed papers into his office and set them down on his table. And we got a picture of he and I and another person holding up this this binder. So yeah, we've done our due diligence with Chomsky, and it went nowhere. And Tony, regarding the presentation by Halsey, I was simply referring to when the study does come out later. It'll be months from now, apparently, and he'll do some kind of a presentation at that point. But we're certainly not waiting. That's absolutely
Yeah,
correct.
yeah. I don't want to. This is a presentation by this organization, which is a subset of 8911 Truth, and it includes Leroy's work. Okay, and I think what we have from Roland is very sufficient to do the job, and everybody can just show that video. I was asking Roland whether if some people wanted to actually do the presentation themselves for the PowerPoint slides, and I don't know, maybe somebody does. I mean, if you feel you know the material well enough, my opinion, and this I would defer to Roland on this, is you could do that. But that's my opinion. I don't know if he wants to, what you want to do there, Roland, whether that's an option or not.
Well, speaking to that, if people feel strongly that they want to do the presentation themselves, then that's fine. I have no problem with that.
Right.
The material itself speaks for itself. I don't see that anybody presenting it is going to throw any. I mean, there's no real way to. It's factual. There's no arguing with it. And if that's what people would prefer to do, that's fine. I have absolutely no conviction that it's got to be the video or else. The other thing that people need to be aware of is that we're preparing another video, which is not done yet, which basically is an improvement upon this video. It's supposed to be. It's done by Dylan Avery, who did Loose Change. And that will be the actual video that we send out, as opposed to the one that people have been looking at. But the material is the same. The only thing that's going to happen is the production qualities, and it's going to be a slightly different format. I haven't seen it yet, but we won't send it out unless we're satisfied that it meets the same standards that we've already set up. And as for reaching out to other people like Noam Chomsky or the media in general, I think once we've started this process and we're underway and we're reaching out, and we're getting feedback, and we're finding out what's happening on, then we can begin to reach out to other organizations. For instance, I don't know, my wife watches Amy Goodman all the time. Amy Goodman has gone on record as saying there needs to be another investigation. She has said that repeatedly. There needs to be another investigation. So I don't see anything wrong with going to Amy Goodman right now and saying, well, now we're calling for another investigation. So I think you need to give us some publicity because we're following up on what you've been saying all along, and see how she reacts to that. In general, we all know that for the mainstream media, touching 9/11 is like the third rail. They don't want to have anything to do with it. They've gotten the word that it's a career killer. It's not going to work. Don't do it. And it's been a very few individuals that have been willing to stand up to that. But the whole point of us getting the engineering profession behind taking a position that these reports are not adequate, they do not meet professional standards, we reject them, needs to be done over. If the engineering profession standing up together through its organizations is saying that, as opposed to a bunch of individuals, if we can get that to happen, then the public is going to have to take notice.
And the media.
And the media, yeah. The media will have no choice if you get engineers in an organized way, which is what we're trying to get to.
I
mean, and to also know the details. I should say that. Many people don't know the details. And that's what this presentation is attempting to do by deconstructing, showing the extreme flaws and problems with the present reports and the non-explanatory nature.
I think his idea was pretty good, though, to possibly have someone video in, like Roland, that can just watch it, you know, in the background and have any additional input or questions at the end.
Yeah, well, that's where we're going to give you a video to show. You can either, right.
But he's saying have a live connection,
like a lifeline.
Oh, I didn't think he was saying that. You mean like over Skype?
Yeah, that's what I meant. You know, whenever the questions are coming, if rather than saying, "Let me take your information down and I can pass it along to Roland," if he's videoed in on the conference in the back on a laptop, and you can, you know, communicate directly with him.
Well, that's asking the presenter to do a lot more. That's a heightened amount of technical logistics that I hate to put on people for.
Yeah.
You know, I mean, we do that's been done occasionally on a big thing, but for this, you're going out giving a presentation to a small group. I mean, I'm plenty willing to do that. I'm sure Roland would be, but to get the presenter would have to get involved in those technical details might be hard to do. So we can just defer the question, but really you're there presenting that information to that group, and you're also asking them to join us and ask their organization to request a new investigation or demand a new investigation.
Yeah.
So yeah, I hear what you're saying, but I don't know that might be hard to do.
One other thing to also keep in mind is that when big events, like let's say, for example, when the Space Shuttle Challenger exploded, they did not have NASA investigate itself. They appointed a board of investigators that were totally independent of NASA. When Columbia, the space shuttle, also exploded, they also brought independent people. So 9/11 was a far bigger scale than the explosion of whether it was Challenger, the space shuttle, or Columbia, the other space shuttle. Yeah. So a question to throw at the beginning also of the presentation is why do they do independent investigation when it's something like Challenger or Columbia, but when it's something 10 times or 100 times bigger, like 9/11, they choose to have the Commerce Department use NIST to do their own.
They're going to tell you the 9/11 Commission was an independent commission, but it really wasn't. It was on par with the Warren Commission. It wasn't really independent.
No, I'm not. I'm talking about NIST now. NIST.
Oh, I understand. Well, it looks like NIST has been politicized.
Yeah.
People within the administration and subsequent administrations were able to control it.
Yeah.
And they must be part of a faction that, you know, if we all believe there's other things that went on here with domestic actors, they must be part of it.
Yeah, I think
because
it's worth mentioning that at the beginning, like making the comparison between the space
shuttles. I agree. They did the space shuttles. Both of those investigations were done properly, and they found the actual cause. These weren't done properly because they didn't want to find the actual cause.
Exactly. Yeah.
Okay, so you know you can't take apart. If you want to make that claim, I think we're just showing. I don't know that I would go there because you might want to. If somebody wants to do that, that's fine. If they can frame that question properly.
I'm just simply saying that here it is something that shows that why do we do independent investigations here but not here? That's just a question to throw out.
Yeah, I agree.
Yeah, well, I think I tried to address that at the end by talking about what we want with a new investigation, and of course, I didn't point out the fact that a really independent investigation couldn't come through a government agency.
Exactly. Yeah. You might like to add that. Actually, you might like to that. Yeah.
Yeah, that's a good point. I would agree with that. That's a point that I thought it was inferred, but you need to state it explicitly to make it clear.
Yeah, mention the space shuttle investigations. Mention that. Yeah.
Right. Good. Okay, you can do that. All right. Anything else anybody wants to raise at this point? Okay, well, I thank everyone for attending, and we will be in contact as usual through the bulletins and following up with what we've learned today and pointing the way forward. As always, you guys have my phone number. Anytime you need to communicate with me, you can call me directly. You know, we're continuing to move forward with this thing. After next week, next Saturday, when we have another webinar, we'll know a lot more about where we are in terms of timing for the kickoff. Meanwhile, we'll continue to do the research on locating all the chapters, and I'll be asking for your physical addresses so that we can locate you in the context of where those chapters are.
I think you can say, Roland, you can say the kickoff or the start of these presentations is not far away. So people don't, you know, the presenters don't lose interest. It's coming soon. We had to do some training here over the last month or so, and it looks like everybody's doing that. So, you know, yeah. It's not that far away.
Yeah, and we have more people that we can bring on board. I tell you, I kept it down to about 30 or so presenters at the very beginning because I didn't want to start off with an unwieldy organization that was too large for us to handle. We want to make sure that what we're doing right, and we'll recruit more people as we go along. I have another a database of more people that we can contact. I've had other people contact us in the meantime, and we'll meet more people as we go out there. So this is a movement that's gonna grow, and we're gonna bring more people on board, and we'll get better at it as we go along.
I have one comment, Roland.
Yeah.
When I was president of ASCE, I received a book called ASCE Official Register, and it lists every branch, every section, all the people involved in ASCE. Now, I'm sure this is something online available to officers or people that are members of ASCE. I didn't know if you had this type of thing for contacting, coming up with a list of your branches and sections.
No, I've been relying on what I could find online, which is everything's online, but that's very concise there. That would be very helpful.
This is the 1 year I had my name in there with being president of the branch. And so that's probably why I got it. But let me try to go online and see whether I can locate a register and using my membership number to get in there.
That would be great.
Jeff, you apparently know people also if you were in that position. So, you know, the kind of thing I was talking about earlier with contacts, you might be helpful there.
That's Michael.
Michael, I'm sorry.
I'm just a small fish.
Well, all of us are, but if we organize this right and we get input from everybody, you know, in a measured way, we can move forward. So I'm just interested in keeping it simple and straightforward, and so everybody knows what's going on and we're all moving forward together. And the contact thing and getting into these places is going to be important. And then, you know, knowing the material is also important. So both things need to happen, and then continuing to grow as far as bringing more people on board and expanding the whole exposure of this. So those three things.
Okay.
All right, Mike. I'll wait for you to get back to me on that. Okay. Let me know if you've had any success.
I'll do that.
All right. Thank you very much for that. That's valuable. Okay. Well, I'm done. If anybody else has anything else to say, we can put an end to this particular session.
I think Kathy has something. Hi, Kathy.
Yeah, am I live now?
Yeah.
Can you hear me? Okay. I just wanted to toss out there, I'd be happy to help with facilitating being able to Skype in Tony if he's available. I know we'll always have the time change difference, but I think that would be very powerful because having given presentations myself, the questions can be overwhelming. I used to bring in Chris Sarnes because his knowledge was so much deeper than mine. And Chris Sarnes would be another person we could use. But the questions can be overwhelming. And I think if your audience gets an instant answer, it is so much more powerful. So I personally feel having that capability figured out and available would be huge. And I'd be happy to help with that. That's all.
Great. Well, I agree. If we can do it, we should do it. It's possible.
I think it's Tony. I think it's a lot to ask of each presenter. Now, why don't we table that for now, okay? And just leave it. If somebody asks a question like that, we'll get back to it. We're not afraid of any questions. As somebody said earlier, we're not. We welcome any critiques. I can't imagine anybody having any of them of any merit, but we're completely open to any questions. Having a video link is a little difficult, Kathy, for what we're trying to do here. There's nothing wrong with, everybody knows here. I'm sure they've all given presentations, and when somebody brings up a question, you get one out of left field here or there that you may not have the answer to right there. There's nothing wrong. It's very professional to say. I'll have to get back to you. That's all.
And
we can't please everybody, and you're not going to.
I understand I understand that you can't answer every question. All I was suggesting is the power of being able to answer it immediately is huge. And I personally would be willing to help, get that dialed up so that it's really easy for the presenters to do. It really, I think the biggest burden would be on people like yourselves, the people who have the really deep knowledge, because you'd have to be available. We'd have to be able to call you real quickly and Skype you in. So
I understand that.
Anyway,
for right now, let's hold
I'll
off
drop
on
it.
that. That might work out down the road, but right now, let's try to keep it a little more simple and get this thing off the ground.
Yeah, and we need also to share the kind of questions that people receive. Like if there was a way for people to connect with Roland, for example, convey the questions that people ask, and then he can distribute that around so people can get an idea about the type of questions. I attended myself a technical debate, if you will, in Bellevue, Washington, a few years ago. It was engineers against engineers, which is very rare. And I found that actually the engineers who were for the official story were from Boeing, most of them, actually all of them. And they had no idea about what happened after the initiation of the collapse. Like they were familiar with the NIST reports, which spoke only up to the point of the initiation of the collapse. Nothing beyond that, the time of the failure and all of that for the big towers. And they were totally unaware of any of that was done by other people. And then the other question that they always raised as an argument actually was, do you know, for a conspiracy like that to work, how many people will have to be involved, and you have to have all these criminals getting their heads together and stuff like that? These were the main two things, actually, that I noticed myself.
That's not a technical reply.
Yeah, the second one was not a technical. Yeah.
And you got to say we're staying to the technical nature of it. We're not going to get involved in that. So I mean, you're just going to have to say, if there's a question that is really difficult to answer, I can't imagine there being too many. This presentation is pretty straightforward, and it goes right to the reports.
Yeah.
So if they want to come up with things like that, you didn't know how many people would have to be involved. Well, we don't know. We just know the reports aren't right. We need to do investigation. That's what I would say.
Yeah.
Okay. Everybody done? Thanks again for coming.
Y'all take care. Thank you.
All right. Nice meeting you all.
See you all. See you, August.
Yeah.